Welcome back to KSIR previous year question and solution classes. Today I will discuss 2016 year paper from part 2. Okay, so and also the subject is classical mechanics. So here the question is like this: an object dropped from sky follows the motion x is equal to of gt square. Then the acceleration of the body, okay, is varies with time, remains constant, varies according to velocity, and varies as square of the distance. So the concept is very simple here. An object dropped from the sky follows the motion x is equal to of gt square. Let us consider, for example, so this is an object chalk piece which is dropped from the sky, its fall, and the equation for this chalk piece or a particle they are given is x is equal to of gt square, and we should calculate acceleration, whether it is depends on time or it is constant. So let's see, if we differentiate this equation with respect to time, we will get dx by dt is equal to of g 2t, and 2 gets cancelled. So dx by dt is nothing but v is equal to gt, and we know that v by t is equal to g. So what is v by t? Since v by t is nothing but acceleration, so therefore from these two equations we can easily write a is equal to g. So acceleration of a particle is constant. Okay, so if a chalk piece drop from the sky, okay, at the height, some height, so it fall on the ground with constant acceleration. So option varies with time, remains constant. So option B is correct. So this is question number 2, and from KSIR paper it is question number 12. The Lagrangian equation of motion for a simple pendulum is. So in these 4 options, so we should find out which one is the equation of motion for of Lagrangian for simple pendulum. Okay, so what is simple pendulum? See, let us consider a small rod. For the small rod, let us, a bob is connected with a small frictionless wire. Now the bob is oscillating like this. Okay, it has some simple harmonic motion. Now we should write a kinetic energy and potential energy. We know that the Lagrangian is nothing but L is equal to T minus V. We should calculate the kinetic energy and also we should calculate the potential energy. So when the bob is connected, let us consider a angular displacement of the bob of the simple pendulum is theta. Okay, that means it has some angular displacement. It has some angular displacement theta. Okay, so and the arc of this is S, which this theta is very small. Then the arc, or from the trigonometric relation we know that sin theta is equal to opposite by hypotenuse, which is equal to, what is opposite? S. It looks like a straight line. Okay, so S divided by hypotenuse is nothing but L. Let us consider L is the length of the bob. Okay, that means from the rod to the bob is L. So L, then sin theta is equal to S by L. If theta is very small, so then sin theta is approximately equal to theta. So therefore theta is equal to S by L. Okay, and let us consider, we know that velocity is nothing but ds by dt. right? Next, so therefore V is equal to, what is S from this relation? S is nothing but L into theta. So therefore d of L theta divided by dt. So then V is equal to, differentiate, L is constant, it is not changing. So L into d theta by dt. So we can write this as V is equal to L into theta dot. So this is the velocity of this bob. Okay, when there is a small displacement, angular displacement takes place. This L theta is that L into theta dot is nothing but angular velocity. It has some angular velocity. Okay, so now, so let's see. Therefore, kinetic energy T is equal to of m, and that V is nothing but L into theta dot square. So this is kinetic energy. So then what is potential energy? See, so let us consider a bob which makes some angle theta. Okay. So let us draw a perpendicular line to this vertical axis. Let us consider this is y axis. Okay, and we know that the potential energy V is nothing but mgh. Height, we should calculate, we should find the height. But at equilibrium, we know that potential energy V is equal to 0 if the bob is exactly at the equatorial. That means, if suppose, let us consider this is the point O. At this point O, okay, so let us consider this is the position of a bob. So here now in this situation there is no potential energy, it is at rest. When the moment the pendulum is start moving, it has some potential energy, it gains some potential energy because it moves opposite to the gravitation of earth gravitation. So it has some gravitational field, it feels some gravitational force. So now it has some potential energy. We should calculate that. So that is, now we should calculate the potential energy here. Let us consider this is the position A, but we should resolve this position A to the vertical axis. So then this distance is B. If suppose this is B, we should calculate this distance OB. So we know that OB, this OB is equal to O, for example, let us consider this is C. So then OC minus BC. So then OB is equal to, what is OC? OC is nothing but length, actual length. So the length of the pendulum. Next, L minus. So what is BC? We should calculate BC. So we know that from this triangle, okay, so from this right angle triangle, if this is theta, this is C, this is B, if this is A, then cos theta is equal to, adjacent side is BC, BC divided by hypotenuse is L, then BC is equal to L cos theta. Therefore BC is equal to L into cos theta. So which is L cos theta, right? So therefore OB is nothing but, if we take L as a common, 1 minus cos theta. So this is H, that means this OB, this is H. Therefore the potential energy V is equal to mg, the potential energy V is equal to mg, H is nothing but L into 1 minus cos theta. So this is kinetic energy and this is potential energy. We know that L is equal to T minus V. So we should substitute here. Then see, L is equal to, kinetic energy is of m L square theta dot square and minus mgl into 1 minus cos theta. So this is Lagrangian for a simple pendulum. Now let us to find the equation of motion for a Lagrangian. So that is dou L by dou T dou by dou T of this dou L by dou theta dot into d by dt minus dou L by dou T, which is equal to 0. So this is the equation of motion. Now therefore what is dou L by dou theta dot? So dou theta dot here differentiate with respect to theta dot. So then we will get 2 cancel. So m into L theta dot d by dt you will get after differentiating this with respect to theta dot. Now differentiate this with respect to d theta. Then so here if I multiply mgl here there is no theta coefficient, so this will be 0, and differentiate this minus into minus plus, and again here we have minus, so minus, and if we differentiate this L with respect to theta and it cos theta, so we know the differentiation of cos theta is nothing but minus sin theta. So again it will be plus sin theta, which is equal to 0. Because differentiation of cos theta is nothing but minus sin theta. So and again see, differentiate this again with respect to t, so then you will get ml theta double dot plus sin theta. So then theta double dot is equal to minus sin theta divided by ml. So okay, and also I forgot to write this mgl coefficient. So plus mgl, and so this is mgl. Therefore here we will get mgl, and ll cancel and mm cancel. Theta double dot is equal to g sin theta, and also this is L square. So then here we will also get L square, and denominator will get L. So theta double dot is equal to g by L into sin theta. So is there an option? In the option they are given it as L as E. So which one is correct? Option A is correct, right? So this is an equation of motion for a simple pendulum. So this is question number 11, which is also based on Lagrangian. So the Lagrangian for a particle of mass m in an electromagnetic field is given by. So this is the Lagrangian. The Lagrangian they only given. Okay. So this is for kinetic energy and this is for potential energy. So this is the Lagrangian if a particle in electromagnetic field, right? So let us, that means if there is a charge particle, if this charge particle is placed in an electromagnetic field, so its Lagrangian is this one, and this is the kinetic energy of this particle and this is the potential energy of this particle. Now we should calculate the momentum conjugate of this Lagrangian along x. Momentum conjugate along x. See, the momentum conjugate is along x is px is equal to dou L by dou x dot. So which is equal to, what is L here? Of m x dot square plus y dot square plus z dot square minus q phi. So this phi is scalar potential of x comma y comma z of t plus q of a of x comma y comma z of t, and this a is vector potential and this phi is scalar potential. Dot v, velocity one more is here. That velocity is also time dependent. So dou L by dou x dot is equal to, if we differentiate this we will get while differentiating x, all other y and z are constants. So it has m x dot, and also we have a x comma y comma z t dot v. V is nothing but what? V is also nothing but x dot plus y dot plus z dot. Now we should differentiate that also with respect to x dot. So then it is plus the coefficient is q of a, right? Q into a. So therefore px is nothing but mx dot plus q into a. Is there any option? Mx dot plus qax. So option C is correct. So this is the momentum conjugate for this charge particle when the charge particle is placed in an external electromagnetic field. So this is question number 13. Let E and P be the energy and momentum of a relativistic particle with rest mass m. That means a particle is moving with a velocity of light approximately equal to the velocity of light. So then what is its total energy? So that is E square is equal to P square C square plus m naught square C power 4, and E square is equal to P square C square minus m naught square C power 4, and E square is equal to m square C power 4 minus P square C square, and this is. So by saying these equations we can easily answer that we know that E square is equal to P square C square plus m naught square C power 4 is the energy expression for a particle which is moving with a velocity of light. Next question is rotation of a vector in a xy plane about a z axis is represented by a 2 cross 2 rotational matrix. So 2 cross 2 rotational matrix we should construct, and what is the trace of that matrix? We should also calculate the trace of that matrix, and we should choose which one is the correct in this 4 option. So here they are given xy plane about the z axis a particle is rotating. That means z axis is constant. So let us consider x plane and y plane. So this is old coordinate. In this old coordinate there is a particle. Now it is rotating. So that means the coordinate is rotating. That means now x is changes to, which makes some angle theta, and it is x prime, the new coordinate, and y is changes and which makes some angle theta, and this is y prime. X to x prime, y to y prime. It is rotating. And now we should calculate the rotation matrix, the elements which is coming, the magnitude and vector which is changing of this vector. So now that is the new coordinate x prime is equal to x cos theta plus y sin theta, and y prime is equal to minus of x sin theta plus y cos theta. If we construct this, so x prime y prime which is equal to cos theta sin theta and minus sin theta cos theta into xy. So this is the matrix. Okay, so that is just like x prime is equal to rz into x. So this rz is the matrix. So rz is equal to cos theta sin theta and minus sin theta cos theta. So what is trace? Trace is nothing but sum of the diagonal elements of the matrix. So that is, if you add these two matrices, so this is trace, diagonal elements, cos theta plus cos theta, 2 cos theta. So answer is 2 cos theta. So option D is correct. So this is the question number 15. If the orbit of a body is given in a polar coordinates r theta is equal to constant, it is under the influence of force that varies as, so these are the four options given. Okay, so let's see. So let us consider the given is r theta is equal to constant, and that constant I am considering as some c. Okay, so now this implies r is equal to c by theta, then 1 by r, see 1 by r is equal to theta by c, theta by c. Now let us consider that 1 by r is equal to u, then 1 by u is nothing but r, but we have an expression that is f of 1 by u into divided by j square u square minus mu is equal to u plus d square u by d theta square. So therefore let us differentiate u with respect to theta. Okay, so sorry, there theta by c is nothing but u. Let us consider theta by c. So let us consider theta by c. Okay, forget. Let us consider 1 by r is equal to u, and so 1 by r is u. So therefore u is equal to c by theta. Now differentiate this, so du with respect to theta d theta, so which gives c, and again differentiate this with respect to theta, so it will be 0. So therefore d square u by d theta square is 0, and this equation becomes, so therefore write f of 1 by u is nothing but r into minus mu divided by j square into, see this is u square. So what is u? U is nothing but 1 by r. So therefore, so write as it is u in is equal to u plus 0. So now after simplification, see, we will get, so f of r is equal to j square u cube divided by mu. So f of r is equal to this constant into u cube. So what is u? U is nothing but 1 by r. So f of r is equal to minus of that constant into 1 by r cube. So therefore option C is correct.